Hello my friends, Algebra 1A, Lesson 1.2. We are talking today about using variables. We're going to be jumping into algebra stuff. So we're going to start with some simple expressions and equations. So we have two learning targets for today. The first one is I can define a variable or variables in the context of a verbal situation. So this is when we're going to look at, you guys call them word problems, but these are really real world examples of how we use algebra. And then I can translate verbal phrases into algebraic expressions and equations. We're going to do both today, and we're going to kind of talk about the difference between them. All right, so for starters, we are going to pick up with some really important vocabulary here: variable, algebraic expression, and then equation. All right, so a variable is a symbol, usually a letter, like X or Y. We use those a lot. That is used to represent a number. And specifically, it's something unknown, because if we knew the number, we would just use the number. So for example, if I ate 5 donuts for breakfast, I would just say, so if somebody said, how many donuts did you eat? I'd say 5. But if we don't know something, then we use that letter to represent the number, and then at some point we might solve to figure out what that number is, but when we're starting we don't know what it is, okay? Now, key thing here, we're going to talk about an expression. An algebraic expression is a math phrase, and it's made up of numbers and operations and variables. The variables are what make it algebraic, okay? If we didn't have any variables and we just had numbers and operation like 2 plus 3, that would be a numeric expression. Now the key thing, really important thing to know, is that an expression has no equal sign. So anytime you've seen a math problem starting from 1st or 2nd grade, like if you were doing an addition worksheet and it would be like 3 plus 5, 7 minus 2 for subtraction, those are all expressions and they don't have equal signs. They just are like blurting out a problem, okay? Now, on the other hand, an equation does have an equal sign. And we're going to be really picky about making sure that we use the correct vocabulary here. Expressions versus equations. And an equation is basically a math statement where two values are equal. And that's why we have the equal sign in them. Okay, so I'm going to go ahead and color in this little star here, because this is important information. And it seems kind of like total common sense. But it is a concept that a lot of students mix up their vocabulary. So we need to be really precise with what we say in class. We make sure we're saying exactly what we mean. All right, so now let's talk about some more vocab, the parts of an expression. Okay, so things we want to talk about, and I'm going to trade this pen in. It wasn't making me super happy. Let's see if there's another purple one. All right, we're going to talk about the variable, the coefficient, the constant, and what is a term. So the variable, of course, that's the letter. So the X here is the variable. The coefficient is the number in front of a variable. And it means multiplication, because remember, we just smoosh them right together. So do you see here 3x? We don't have a multiplication symbol in there. It's understood. So the coefficient in this expression is the 3. Now I'm going to jump all the way over to term, because when you see those smooshed together and there's no addition or subtraction signs there, all of this together, all of that is a term. So 3x multiplied together is a term. And terms are separated by addition and subtraction signs. Okay, and I like to think of terms as being chocolate chip cookies. So inside this term, there's a coefficient and a variable. They're their own thing, but then when you smoosh them together, you get what I call that chocolate chip cookie, which is the term, because it's like You put together some dough, you put together some chocolate chips, and then you bake it, and it sticks together as one. All right, and now here we have an addition sign. So this 3x is separate from this 5. The 5 is the constant, and the constant is a number that does not change. Interestingly enough, the 5 is also a term, okay, because the 3x and the 5 are separated by this addition sign. This term only has one piece and it doesn't have a variable in it. So a term can be a number all by itself, it can be a variable by itself, or it can be a number and a variable together, okay? So those are some things, those are words we're going to be using a lot, need to understand them so you know what we're talking about. Okay, so a couple extra important details here. Expressions do not have equal signs. Equations do have equal signs. You might want to highlight that so that really jumps out at you when you're using your notes. Along with that, we have some other vocabulary. When we're discussing doing the computation work that we do, we have two verbs we use. One is evaluate, and so if we are figuring out the value of an expression, we say evaluate. When we are finding the value of a variable, we solve an equation, okay? Two completely different things. So we don't say solve when we're talking about expressions, and that's going to be something you and I are going to maybe have words about because you've been probably saying solve all your life since elementary school, and we want to make sure we're precise. Now, the next thing I want to highlight, and I haven't really said this before, equations have expressions in them. All right? How about a green highlighter? Equations have expressions in them. And what that means is that when we have the equal sign, that's what turns it into an equation. So we could have 3x plus 5 on one side, and on the other side we could have an expression that might just be a number. So 3x plus 5 is an expression, 27 is also an expression. What we're going to get into in our next unit is equations that are a little bit longer. So maybe like something with a distributive property, 2 times x minus 1 is equal to 3x plus 8. Okay, so if you look, here's the equal sign. There's an expression here. There's an expression here. So there are expressions inside equations, but as soon as you put this equal sign in here, now it's an equation. All right, so there's some very picky vocabulary. All right, it's almost 8 minutes on the video. Let me keep going. This might be a long one. All right, writing algebraic expressions. I have a saying I like to say. Pencils down, hands up. Okay? What I have noticed in the course of my math teaching is that students kind of want to have this like get her done attitude. They just want to write stuff down. Okay? And I'm going to tell you, you are going to be much better off if we stop and analyze the situation and think about it first, put it in real world, understandable thoughts, a picture in your brain, use your life experience to really make sense of things, and the expressions and equations will almost write themselves once you do that. Okay, so pencils down, hands up. You're probably going to hear me say that a lot. All right, now, whenever we write an expression or an equation, there's going to be something we don't know. And so what we define a variable, and what that means is we know a variable replaces a number, right? It stands in. I'm not saying give me the definition. I'm saying define what we're going to use it for. So state what the variable is going to represent and be specific. So it might be something like let D equal how many donuts Bat ate, okay? And if you remember the example I gave you on the first page, I said, okay, if I knew that if I ate 5 donuts this morning, I would just say, hey, I ate 5 donuts, all right? But if I don't know, then, and I'm looking for that, I'm going to define the variable, and that way I know exactly what I'm looking for, and then when I find it, I'll know what it is I found, okay? All right, so we're going to do 5 examples here. So it might be a little bit of a lengthy video. All right, so we're going to write an expression, not an equation, so no equal signs. So no equal signs anywhere on this page. My age 4 years ago. So pause. we're looking for an age. So that's a number, and we don't know, okay? What I do know, though, is that whatever age I am now, the number assigned to my age 4 years ago is going to be a smaller number. Does that make sense? Like if 4 years ago, if I was 10, then I'd be 14 now. So my current age is bigger than the age I was before. All right? So I don't know how old I am now. That's what I'm going to use my variable for. Let A equal my age now. All right? And so what I need to think about is, if I take my age now, how do I get to my age before? I'm not going to add to my current age because that would make me older 4 years ago. I'm going to have to subtract from my current age. So if I take my age now and I subtract 4 years, this expression here would represent how old I was 4 years ago. Okay? Twice as many cookies as Kylie ate. Okay, so what are we looking at here? We don't know cookies. And I like to use a letter that represents what I'm talking about. So when I define my variable, I'm going to let C stand for cookies. So I'm going to say the number of cookies. And the number of cookies what? I can't just say cookies. I need to be specific. The number of cookies that Kylie ate. That's my son's girlfriend, by the way. Just a little tidbit of information for you there. All right, twice as many. Twice as many means we're going to multiply times 2, right? So in this case, we're going to multiply specifically by 2. Now, we never use the x in algebra. We just smoosh together the number and the letter. So if I take the C and I put a 2 in front of it, that is going to represent twice as many cookies. All right, one more. 6 less than the number of children. This is one we're going to have to watch out for. This one is a tricky question, so let's highlight this. Students mess up less than all the time, and the reason is because the way we read it and then the way we translate it to math are backwards, okay? Backwards from the way it sounds. So 6 less than the number of children. All right, what is it we don't know? We don't know how many children there are. We just know whatever it is we're talking about is less than that number. So I'm going to let C equal number of children. And side note, all these practicing of me defining variables, you are going to have to define a variable. Now, we have the number of children, and then whatever it is we're looking at is 6 less than that. Okay? So I'm going to get a red pen here. So if students look at this and they try to go in order, they're likely to do this. 6 less than C. This is not okay. This is not the way to do this. Okay? And that's why I said it's backwards. So if we have 6 less than the number of children, think of it this way. We have the number of children, and if we take 6 away from that amount, we now have 6 less than the number of children. So when we talk about less than, notice the C came first, the 6 came after the subtraction sign. It's backwards than the way it reads. Don't do this, do this. All right, getting a little bit more complicated. All of those had one operation. Now we're going to pay attention. We're going to need more than one operation. 10 plus the quotient of a number and 3. All right. There's an unknown number here, so we're going to say let n equal the unknown number. And now we have 10 plus, the plus is going to be addition. We also have a quotient. Quotient is going to be division. We're going to have 2 operations in this. Okay, 10 plus the quotient of a number and 3. So in this case, we can write it exactly the way it sounds. 10 plus the quotient, fraction bar, of a number and 3. Now, whenever we have addition, we can switch the order. We cannot switch the order of the n and the 3 because quotient of n and 3 means n on top, 3 on bottom. But if you were to write this as n over 3 plus 10, it has the same meaning, okay? Because addition can switch the order. We cannot switch the order here because subtraction, that doesn't work. When we write multiplication, we always put the number in front of the letter, okay? And subtraction, we can't switch. So this is the first one out of our examples that we could switch the order if we wanted to. All right, I'm going to pause for a second because what I want you to do is I want you to read this one and think it through and see what you come up with. All right, the sum of 13 and triple a number. So here we have sum is going to mean addition. Triple a number, that's just like up above when we said twice. Triple a number means multiply times 3. So multiply. All right, again, we have an unknown number. So I'm going to say let n equal the unknown number. And now we're going to write the expression. So we're going to start with the sum of 13 and triple a number. So if we start with 13, we add to that 3 times this number. And again, we smoosh them together. So n over 3 is quotient. 3n is multiplication. All right, let me look real quick and see what else we have left to do. You know what? I think I'm going to just do one real short video separately. I'm going to stop here. It's more than 15 minutes. And watch the next one when you're ready to do equations.